Good afternoon, students. Today I am discussing about the principle of DC motors, that means working principle of DC motors, and what are the components we use in DC motors. Now, to make a DC motor, to construct a DC motor, we need a core, we need a coil, we need a commutator, a brushes, a concave cylindrical magnet, and some battery or electric source. Now these are the battery or electric source. We name that EMF of that battery is E. Now another thing, we need two commutator, that means a ring, semicircular ring R1 and R2. This is a commutator, we can say we need a commutator. Another concave cylindrical magnet, there is a concave cylindrical magnet. Another one part is north, this is a type of U-shaped magnet, and first one cylindrical magnet is UN north and another end is south is here. So from north to south some magnetic field lines passes, that means magnetic field intensity is directed from north to south direction. Okay, next we use two brushes, one B1 and another B2, which will connect with the commutator rings R1 and R2 right now, and we use a coil. Now from commutator take a wire and wound a wire in a rectangular shape like that. After some turning then come at end and connect it to the second ring of the commutator. This is the coil. This makes a type of coil like that. Okay, there have some turnings and also it have some, this is the coils and it have some turnings also here, and after turning it will connect with the ring 2. Okay, and take a core like soft iron laminated cylinder. Inside this rectangular shape coil, put a soft iron core. As you put the soft iron core inside the laminated cylinder, so the force experienced by this coil due to this magnetic field and current flowing is greater, and it uses as a DC motor and rotates. Now what happens? Now if we there need a switch or key. If we switch on the key, now current will flow through this direction towards the brushes 1 and ring 1. Now from ring 1 current will flow towards the A point, A to B. For a single, if we take a single rectangular shape and there have some total number of turns of that rectangular shape, if we take a single, look at that, from A to B the current will flow for first time, and from B to C and C to D, then reach at the point commutator of ring 2 and reach at the commutator of ring 2, and from that it goes to the brush 2 and reach at the negative terminal of the battery. Now what happened, when switch on, the current will flow in that AB part, AB section, the current will flow in that direction, upward direction, right? And for that magnet there will be a magnetic field towards the north to south direction. So out of this we can use the Fleming's left hand rule to find the force experienced by this coil. We use the Fleming's left hand rule like that. There will be the current. Fleming's left hand rule says that you take your left hand and forefinger, middle finger and thumb and put it in perpendicularly one each another. Now if your forefinger shows the direction of the magnetic field, If your forefinger is shows the direction of the magnetic field lines and your middle finger shows the direction of the current flowing through it, then your thumb shows the force experienced by that coil due to this magnetic field and current. Now, forefinger shows the direction of the magnetic field and current flowing through it directed towards the upward direction for AB. Now, as your thumb is directed to the downward of the book or copy, downward of that copy, so we can say that it experiences a force to the downward direction. Now similarly, for if we talk about the CD direction coil, part of the coil. Now this CD part, forefinger is showing the direction of the magnetic field and your middle finger is showing the direction of the current flowing through this coil and your thumb is showing the force experienced by CD part of that coil. Now for that rectangular coil, this AB part experiences a force to the downward direction to inside this copy and this CD part directed a force, experienced a force to the upward side. So it gains or experience a couple of moment of force because there have a force and similarly there have a force in the upward and there have a force in downward direction. So it experiences a couple of moment of force and due to this there have a turning effect. So due to this turning effect, this coil will rotate. After half rotation, this CD part reach at the point of AB and this AB part reach at the point of CD. Now when after half rotation this B reach at point here, this A reach at point here and this D reach at point here and this C is reached at point here. Now for that time commutator, these two rings of that commutator also rotates and for that half rotation this ring 2 will place at the ring 1 place. Ring 2 is reached at the place of ring 1 and ring 1 is placed at the ring 2. Now this brass 1 is connect with ring 2 and brass 2 connect with ring 1 and from now for that second half cycle what happens, the current will flow through this part towards B1, then ring 2 and from D part, D to C, C to B, B to A to ring 1, ring 1 to brass 2 and then goes to the negative terminal of the cell. Now for that second part, this DC portion, the current will flow from D to C portion and experiences a downward force similarly and this BA part experiences a force upward similarly like the previous. So it will again rotate a half cycle. After rotating half cycle, this AB part again comes to at AB portion and CD part again comes to at CD portion. Similarly same thing will happen again and again and for that case how many times current will flow through this coil, this coil will rotate again and again. This coil gets an rotational motion. So as this coil gets an rotational motion, so it will rotate again and again. So it have an rotational motion and it converts this electrical energy for this rotational motion, that means mechanical energy. Now what is the direction of the rotation? Like that, this is the direction of rotation. This part comes upward, then downward, then upward, then downward, like that. This is the rotational motion. So if we connect a blade here